Hello everybody, a warm welcome to Talking Mathematics. Mathematics is an engaging topic and must be covered, of course. This is particularly true for statistics and probability, which are increasingly significant. Knowledge of statistics and probability is useful if you want to better understand the changing world around us. So let's begin. Among other things, that has to do with delightful dice. Allow yourself to be amazed. To be more specific, today we are dealing with statistics, a branch of mathematics that's all about data. How can we collect data? Why do we collect data? Do regular patterns exist that we can exploit? We have just mentioned that statistics is about handling data. Above all, however, it's about handling data correctly. Let's look at an example. The class representative is to be elected in a class. Amma, Lynn, Noah and Kofi have run for the position. You see the results on the slide. Even for young students, it is clear that Amma will be the new class representative because she received the most votes. Kofi came in second and will be her deputy. Any other result would not be the correct handling of data and would not be accepted by the class. What do we learn from this? Quite simply, statistics at school can build upon everyday examples in this context. The next example is also simple and relies on the collection of data. The basis is a survey on how the students get to school. It's very clear that at this school, most students take the bus, the bicycle comes in second, the car is in third place, and the fewest number of students walk to school. Here we can see how useful a good representation of data is. In the pie chart shown here, also you cannot see the individual tallies anymore. At a glance, you can see that bicycles and buses make up a very high share of the listed transportation options. But what do we need data for anyway? For example, to make decisions on a sound basis in more or less difficult situations. You could, for example, advise the school involved on the last slide to provide bike racks based on the data. Let's look at another example and ask which means of transportation are actually safe. In this case, we can obtain a suitable database from the German Federal Statistical Office. Based on the data, we created a table that provides information on traffic death in 2018. Obviously, most of the deceased were traveling by car, but the counts are also high for people riding motorcycles, 50cc and larger, simply walking and riding bicycles. You immediately see that buses, trains and trams are apparently very safe means of transportation. Naturally, it would be useful in this case to know how many people use these means of transportation, to compare absolute and relative numbers. We leave that out of the equation for now to keep from getting too complicated right away. Many possibilities exist for collecting data. They also include observation. If you would like to know whether an intersection is overcrowded, it makes sense to count how many vehicles are waiting at the intersection during a traffic light cycle and how many vehicles make it through the intersection. Heard this all before? Sounds as tempting as yesterday's coffee? Sure, we also can use cold coffee to collect data. And I've done just that. On the right side of the chart, you can see what happens if you let hot coffee cool down for about 70 minutes. It goes from around 80 degrees Celsius down to about 30 degrees. But I would like to have you participate in the process. That is a cup of coffee. That is a thermometer I held in the coffee. You have to strain your eyes a little, but you see the temperature of almost 80 degrees Celsius. And now you see how the coffee cools down at the original speed. It starts out quite fast. It is now 78 degrees, goes down to 77.8, 77.7. Then I used time-lapse because it is really boring to watch coffee cool down for more than an hour. After about 70 minutes, it is a bit below 30 degrees. However, you can also recognize something else, and to do so you have to scroll back briefly. It is actually a nice exponential function produced by the results. You see that you can do this with simple household objects and in principle in every classroom too. Let's do another experiment. Let's roll a die. We roll it 10 times, 100 times, 1,000 times and ask ourselves whether a 6 will always turn up in the results. What do you think? I actually rolled a die. Certainly it was luck that when I rolled the die 10 times, all numbers turned up, including the 6. You probably would have expected that for 100 rolls. Would you also have expected the 2 to be relatively far behind? Presumably not. However, this expectation evidently didn't matter to chance. What you see here is now the results for 1,000 rolls. A tally sheet no longer made sense in this case, but we see that these numbers are closer together. In particular, the 2 noticeably caught up. As you know, the 6 plays a key role in many games, but you sometimes get the impression that you roll it less often. No, in this example, that's not the case, not at all. It was apparently equally difficult to roll a 6 or any other number. Agreed? Have we thus proven that all numbers between 1 and 6 turn up at approximately the same frequency when a die is rolled? Not really. However, the following assumption is reasonable. If you roll a non-manipulated die n times, each of the events 1, 2, 3, 4, 5, 6 should occur approximately n6 times when n is large. Rolling a die is a Laplace experiment. In such an experiment, all results occur equally often in the long run. This is Pierre-Simon de Laplace, a mathematician who was influential in the late 18th century and in the early 19th century. In particular, he made important contributions to statistics and probability. The law of large numbers applies to Laplace experiments. If you conduct a random experiment a very large number of times, then the relative frequency becomes closer to the theoretical probability. And we now just use this term intuitively. In simple terms, we need a very large number of experiments, as with our rolling a die, to be reasonably certain that a conjecture is true. Let's take a look back. We have elected a class representative, conducted a survey on how students get to school. We have considered the safety of means of transportation and observed the traffic at an intersection. Also, we watched coffee get cold and, enthusiastically, rolled a die. In this process, we have obtained very different data in very different ways and shown it differently. So one thing is certain, statistics brings variety to our everyday lives and not only at school. This was a brief introduction to data collection. Thank you for listening and for your interest. Hope to see you soon.